So now we're going to explain the correspondence between permutations and rook placements, where you place n rooks on an n by n board in which all the squares are white. Okay, so here we have a 5 by 5 board. All the squares are white, so we can place rooks anywhere. And we want to place 5 rooks on it in such a way that none of them can attack each other. So you have to have 1 rook in every row and 1 rook in every column. Okay, so let's start trying to place rooks like that. We place a rook in column 4, here say, and then in 2, and then next one can't go in columns 1 or 4, so we place it in column 3 say, and then maybe the next one in column 5, and the next one in column 2. Okay, so now here we've written the placement of the rook in each row. So the first row we've got column 4, second row column 1, third row column 3, fourth row column 5, fifth row column 2. And, and so all these are numbers in the range 1 to 5, and we're not allowed to place any 2 rooks in the same column, so so these numbers have to be all different. So they have to, you've got 5 numbers all different in the range 1 to 5, so each number has to appear exactly once. So that means that this 4, 1, 3, 5, 2 has to be a permutation. It has to be a list containing 1, 2, 3, 4, 5 in some order, each possibility appearing precisely once. Okay, so that's permutation. Over here, we've listed all possible permutations of 1, 2, 3, 4, 5. The number of such permutations is 5 factorial, it's 120. So we've got 120 different permutations in this table, and we've picked out one of them by placing rooks like this. Conversely, if we pick any permutation like this, 5, 2, 3, 4, 1, then we can just place rooks in the corresponding columns, one in rook in 5, then column 2, then column 3, then column 4, then column 1, corresponding to the 5, 2, 3, 4, 1 in the permutation. And because it's a permutation, these rooks end up in different columns. They can't attack each other. So we've got a configuration of 5 non-challenging rooks on the 5 by 5 board. So this procedure gives us a one-to-one correspondence between permutations on the one hand, and on the other hand, legitimate ways of placing 5 rooks on a 5 by 5 blank board. And of course that works for any n. If you've got an n by n blank board, then the legitimate placements of n rooks on that board, they correspond to permutations of 1 up to n, and so there are n factorial of them.